Hi everyone, welcome back to Stoichiometry Chem Corner. In today's video, we are continuing the AP Chemistry Basic Series. As you know, it's not just for AP students. Honors Chemistry or other students struggling with this kind of topic, I'm damn sure it will be super helpful. So the whole playlist I'm pinning here so you can check it out. Let's get started. In today's episode, we are going to describe about stoichiometry. It's very important but not a rocket science. Let's see. So let's consider a balanced chemical reaction. See, all the stoichiometry reaction is starting with a balanced chemical reaction. For example, H2 is reacting with the O2, they will give H2O, right? And as you know, it's not balanced. How do you balance this one? Yes, 2 hydrogen is here, so you can write a 2 here, and here is 2 water. So now, in the left side there is 4 hydrogen, and the right side there is also 4 hydrogen, and 2 oxygen in the left side, 2 oxygen in the right side. So it's a balanced chemical reaction. Every stoichiometric calculation start with the balanced chemical reaction. So make sure you have to first balance the reaction before you are doing the stoichiometric calculations. Okay, so what is this coefficient meaning? What they meant for actually? This 2, there is 2H2, there is 1O2 and 2H2O. What is this number? These numbers actually represent their mole. It's not the actual mole, but the ratio. Okay, so what is the meaning? 2 mole of hydrogen. If 2 mole of hydrogen is there, so it's an if clause, right? If 2 moles of hydrogen is there, it requires 1 mole of oxygen and it will form 2 mole of water. That is the meaning. So this coefficient is actually their numbers of mole, but just like ratio. Suppose there is a 4 moles of hydrogen. What does it mean? 4 moles of hydrogen require, see the ratio 2:1. So 4 mole of hydrogen is originally, if it were, then it require 2 mole of oxygen. Isn't it? That's the ratio 2:1. So it requires 2 moles of oxygen so that they will form 4 moles of water. So that idea is actually you can get from the stoichiometry. Otherwise, they were not talking about the actual numbers. The meaning is not like actually 2 moles of hydrogen is there, 1 mole of oxygen is not there. That's not the concept. Okay, they are just numbers, like the ratios. So what are the ratios you can write from this chemical reaction, the balanced chemical reaction? So 2 moles of hydrogen, you can write the mole ratio like 2 moles of water, isn't it? Because hydrogen and water related in this ratio. Or the reciprocal is always same. The 2 moles of water, you can write 2 moles of hydrogen. Similarly, 2 moles of hydrogen, you can relate with the oxygen. So that 1 mole of oxygen only there. The reciprocal is always true. 1 mole of oxygen require 2 mole of hydrogen. Similarly, 2 mole of water is related with the oxygen we already discussed. Okay, everything we already discussed, because hydrogen ratio and oxygen ratio we already, oxygen ratio we didn't take. So you can write 1 mole of oxygen or 1 mole of oxygen over 2 mole of hydrogen. So sorry, water. So these are the mole ratio. So these mole ratio you can get from the balanced chemical reaction. So that's why I'm telling these are just ratios only. Okay. Now you tell me if this is the ratio. Once again, I'm writing here. So what may be the question? First question be like, if 10 moles of hydrogen is there, how many moles of water formed? Or how many moles of oxygen required? Yes, mere looking you can tell. See the ratio 2:1. So 5 moles of 5 moles of oxygen formed and 10 moles of water. 5 moles of oxygen required and 10 moles of water formed. Isn't it? So in this way, you can convert some moles of A to the moles of B by using the mole ratio. So what should be the mole ratio? Here you need to cancel the moles when you are starting like through dimension analysis. I'm just showing the dimension analysis. If 10 moles of hydrogen is there, how do you convert it to oxygen? Yes, 10 moles of hydrogen, you need to cancel the moles of hydrogen, so it should be the bottom, and oxygen you can take at the top and see the ratio. Oxygen, hydrogen, what is the relationship? See, oxygen is 1, so you can write the coefficient 1, and hydrogen is 2, the coefficient, so that you can write the 2. This is the dimensional analysis. See, so that you can get the 5 moles of oxygen. That's how we are getting this answer. Okay, through dimensional analysis, this is the way. So moles of A, you are converting to moles of B. You are using the mole ratio, like mole of A have to be the bottom and moles of B have to be the top. Okay, that ratio you need to use. That is the first thing. Okay, now what my question? Can I use this equation? Can I use this balanced equation? And can I say if 2 grams of hydrogen is reacting with or it require 1 gram of oxygen and they will form 2 grams of water. Is that right? It's not right, isn't it? Because 2 gram of hydrogen is not the molar ratio. When we think about molar ratio, it will be wrong. The gram and mole, these are two different units. So these are just mole ratios only. We can't use with the mass, the gram. Okay. So if you want this gram or what may be the answer, like 2 gram of hydrogen require how many grams of oxygen or how many grams of water? If that is where the question, you have to convert this grams to mole first. Okay, moles of hydrogen, and then you can take the mole ratio and then you can convert the moles of grams of oxygen. Okay, so what my thing? First, I need to start with the 2 grams of hydrogen. So what is my aim? I need to convert to the moles of hydrogen because I knew only in the molar ratio. Okay, so here 1 mole of gram I need to cancel. So what is the way I can change to moles of hydrogen? Yes, molar mass, by using the molar mass. So molar mass of hydrogen, I think it's 2.016. 0.016 gram hydrogen is equal to 1 mole of hydrogen, right? Okay, so now the gram is changed to moles of hydrogen. Now I can use the mole ratio. So this time also I need to cancel the moles of hydrogen, and if I need moles of oxygen, I can write at the top, and the ratio is 1 is their coefficient and 2 is here coefficient. And now I can again change to the grams of oxygen because 1 mole of oxygen is equal to the 32 grams of oxygen. By using the molar mass, I can do this one. Okay, so see the dimensional analysis, the whole thing. This one cancel, and this one cancel. So finally you got the answer with the grams of oxygen. Okay, that's the way of doing the problem. So every time use this kind of dimensional analysis. Okay, so do not convert directly grams to the other gram. So now what you want to do, if they were given with grams of some A, first you need to convert to grams to moles of A, right? By using the molar mass. So see, gram you need to cancel out, so that you have to divide with the molar mass of A. Okay, then your aim is to convert to moles of B. So again you can use the mole ratio. This time moles of A have to cancel, so that should be the bottom and the moles of B should be the top. Okay, and then the moles of B have to convert to the grams of B by using the molar mass. So this time moles of B at the, see the thing, moles of B at the top. So moles of A, like the molar mass have to be multiplied. Okay, grams of B have to be multiplied because the mole you need to cancel, so mole should be the bottom. So that's all. That's the whole stoichiometry actually. We are using the same the simple principle for every question. Clear? The only thing you need to keep in mind, these ratios are mole ratio. If gram, first convert to mole and then mole to mole conversion. Clear? So let's see this question. So that's the question, laughing gas, nitrous oxide. Sometimes used an anesthetic, okay, they were given the equation. So this is the balanced chemical equation. NH4NO3 gives N2O plus 2H2O. Okay, so the question, how many grams of NH4NO3 are required to produce 33 grams of N2O? So if 33 grams of N2 is there, how much NH4NO3 is needed? Okay, Again, always start with the question. Question is about 33 grams of N2O. So what is your aim? It have to be converted to grams of ammonium nitrate. You know the method. The grams of N2O have to cancel and the relation is 1 mole. 1 mole N2O is equal to the molar mass of N2O. I think it's 44.01. Yes, 40.01. And then you can convert to the 1 mole N2O, sorry, N2O to the the ammonium nitrate that's we need. So NH4NO3. Why I'm writing 1 here? Because the coefficient of both of them is 1. Then yes, 1 mole NH3NO3 is, the molar mass is 80.043 is the molar mass. Okay, so that you can get the answer. I got some 60.02 grams of ammonium nitrate. So then the next question is how many grams of water are produced in this reaction? So again the things are same, like you can start with the 33 grams of N2O. So first thing you need to convert to mole. So again 44.01 grams of N2O is equal with a 1 mole of N2O. Then this time you need to change to water. How many grams of water are produced? So water ratio have to take. So moles of N2O at the bottom and moles of water at the top. So see the ratio. Water coefficient is 2 and the N2O coefficient is 1. That's it. Then the gram, final conversion gram. So 1 mole of water is equal to the 18 grams of water. So that's all. The whole thing will give the answer. I think it's 27.02 grams of water. So that's all the stoichiometry. But limiting reagent like that concept is there. That is much more complicated than this. Nothing, it's easy, but we need to take care of more about that one. Okay, that we can do in next video. So that's all for today's video. If you found this helpful, please like, share and subscribe for more videos. Until then, keep learning, keep experimenting. Bye.